Today what we're going to look at is identifying equivalent algebraic expressions. So in this particular problem, they're giving you an expression for A, and it is 6 times the quantity 5x minus 2. Now, you should be able to use distributive property to remove the parentheses. I have this on a different video, so I'm going to hope that everyone knows that they would take the 6 and multiply it by the first term, and it would be 6 times 5x. You keep your sign of operation, which is subtraction, and then go ahead and multiply the 6 times 2. The first part is actually called factored form, and students should have this in their math notebook. And the second one would be expanded form. Students need to recognize what they look like and what these are actually called. And it's going to be important when you are looking at something like this, when you're looking at a problem like this, that you do recognize that you do have something that's in factored form. You're going to get it into expanded form, and then you should also simplify it. I'm writing this on my smartboard, and students should be writing this in their notebooks when they are solving the problem. Then we go back and we look at order of operations. There are no parentheses, there are no exponents. We do have multiplication going on, so we would be multiplying 6 times 5x, which is the same as saying 6 times 5 times x, because 5 is the coefficient, x is the variable, and we know multiplication is going on. So we would say 6 times 5 is 30 times x would give us 30x. Keep the sign of operation, which is subtraction. 6 times 2 would give us our 12. So now at this point, we're trying to see if there is some type of an equivalent fraction that is going to look like this, which would be 30x minus 12, or perhaps something that looks like this. Our first choice, 11x minus 2, well, that certainly doesn't look like either one of these. Now we have the 6 times 5x minus 6 times 2, which, yes, that would be a choice. That would be this particular problem expression in expanded form. And then the next one is 30x minus 2. That's not correct, but we have 30x minus 12, which is the same as what we have right here. So that would be an option. And then you would be done, and you could move on to the next problem. Now, I want to do something here because some students would be able to take a look at a problem like A and put in a number, substitute a variable. I don't think it's a good idea to use 0 or 1 because sometimes 1 works and it doesn't work with another number, and you may want to test more than one number. But in this regard, we'll go ahead and look at the value of x equaling 2. So if I take this problem and I have 6 times 5 times x is going to be 2 minus 2, and then I'll look in my parenthesis, I'll have 6 times 5 times 2 gives us 10 minus 2, and so we'll have 6 times 10 minus 2 is going to give us 8, and then that would end up with a product of 48. So we're looking for 48. The value would have to be 48 at this time. So we'll take a look at the next one, and we have 11x, so 11 times 2 minus 2. We'll take our 11 times 2, which will give us 22 minus 2. 22 minus 2 gives us 20. 20 does not equal the 48 that we need, so that's not going to be correct, and we already knew that. Let's take a look at the next one. We have 6 times 5, 5 times x equals 2, minus 6 times 2. So we're going to go ahead and do our order of operations. We'll take these. 6 times 5 is going to give us 30, times 2 will give us 60. 60 minus 6 times 2 will give us 12. 60 minus 12 gives us 48. That's our difference. 48 does equal 48. Therefore, this would be true. Scoop that over, wrong one. And that would be true. And so we knew it was true from the previous computations. Let's look at the second last one. We have 30 times 2 minus 2. Notice I substituted the x with the 2. 30 times 2 is going to give us 60 minus 2. 60 minus 2 will give us 58. That does not equal our 48. That would not be correct, and we knew that as well. And then we'll take a look at the last one. Take a look at the last one here. And we have 30 times x, x equals 2 minus 12. 30 times 2 would give us 60 minus 12. 60 minus 12 will give us a difference of 48. 48 does equal 48. Therefore, that would be an option. That's what we got the first time around, and it would work. So you could either go ahead and make your expression from factored form to expanded form to simplifying it, or you could go ahead and substitute a number in. The next one we're looking at would be B. They're giving us 7y plus 6y plus 2y. I'm asking the students to make sure that they understand terms are separated by addition or subtraction signs. Here we have 3 terms. One would be 7y. The second term is going to be 6y, and then the last term we have would be 2y. Now, sometimes I'm telling the students that they should look at the term and the sign in front of it. So if that were the case, I would go ahead and I would look at this term with the sign in front of it. I would look at this term and the sign in front of it. And my first term, the 7, I don't have a sign, but since there is no sign, we would know it's a positive. So now we can go ahead and say I have 3 terms. Are they like terms? Yes. We have 3 terms that have a y as its variable. They have the same last name, so we can simply add the coefficients. 7 plus 6 plus 2 is going to give us 15. We keep our y. Take a look at our selections. Well, the first one is 15y. I'm cautioning the students when they say 15y and that's the first choice, make sure they look that they're supposed to get all of them. Don't stop at the first choice. Read on. 8y minus 7y. Definitely like terms, and we would have a difference, and we would just have 1y, which is not what we needed. We need 15y. Take a look at the third choice. We have 7y's plus 8y's. Those are like terms. Coefficients add up to 15, and we have 15y. They have the same last name. We can combine the terms. The last one is 15 plus y. We have 2 terms. 15 is a constant. Y would be our variable. They are not like terms. We cannot combine them. Therefore, our only choices would be the first and the third. And that's it. We would be done.